Today we're going to look at graphing lines in slope-intercept form. Slope-intercept form looks like this, so you can see that these are all y equals. So today we're going to look at graphing things in slope-intercept form. So we have the m, or what is being multiplied to the x, is called the slope. That gives you the set of stairs on how we're getting to that next point. The b in the problem is the y-intercept. It's where it crosses the y-axis. So remember, this is your y-axis and this is your x-axis. So you can see, where does it cross the y-axis? That would be your b. So this b in this problem is said to be at +1. So b is at +1. And the slope, again, the slope is the set of stairs. So the slope is what we call the rise over the run. Since this is going uphill, so if you were walking along this, you'd be going uphill, so that is a positive slope. So here we're going uphill, so that's a positive slope, and we're going up 3 units and running 1. So we're going up 3 over 1, or we're going down 3 and over 1. So we say that our rise in this problem, or our slope in this problem, is up 3 over 1. So we could write the equation of this line. So if we go back, we could write the equation of this line, and we could say this line has a slope of 3, right? Up 3 over 1, and 3 over 1 is 3 divided by 1 is just 3. Got to have the x there. And then where does it touch the y-axis is at +1. So this line has an equation of y equals 3x plus 1. So we're going to use the slope and the y-intercept to graph these lines. So let's get started. Number 1, first you want to identify the slope. The slope is always what's being multiplied to the x. So the slope in this problem is 2, which can be written as 2 over 1, and that will tell us our rise and our run. It is a positive slope, so our line has to be slanting uphill since it is a positive slope. What is the b in this problem? So we've got our m, right? We've got our m, and then what is our b? Our b is where does it touch the y-intercept, or the y-axis. It's going to cross the y-axis at -3. So that means our b is -3. So on our y-axis, not our x-axis, on the y-axis, we want to go down to -3 because this is 0 and -1, -2, -3. So we want to start at -3. That's where we're going to start, is always at our y-intercept. Then we're going to use the slope, which is our stairs, which is up 2 over 1, up 2 over 1. So from that starting point, we're going to go up 2 blocks, 2 squares, and we're going to run 1 square, and then new dot. And then we're just going to keep going up 2 over 1, up 2 over 1. So from that new blue point, we're going to go up 2 squares and over a square, and we could just keep doing that. Up 2 over 1, up 2 over 1, up 2 over 1. And that gives you the slant or the steepness of the slope. We can also go back to the y-intercept and go down 2 blocks and over 1, and down 2 blocks and over 1. So here you have your line, and the line that when you graph, you're actually graphing solutions. So any point that is on this line will actually make this equation true. So you're actually graphing solutions. Any point that is not on the line is not a solution. So this point will not make this sentence true. Only these points that are on the line will make that sentence true. So when you're graphing, you're actually graphing solutions. So let's look at number 2. So identify the slope, right? The slope is what is being multiplied to the x. So our slope in this problem is a -1/3. So remember, we're going to rise 1 and run 3, but it is a negative slope, so we have to be slanting downhill. So negative is going downhill. And where is our y-intercept? Our y-intercept is at +2. And remember, that is on our y-axis. That's where we're going to start. So we're going to start at +2. That is your b. And this is your m. We're going to start at 2. And from there, we're going to go up 1 block and we're going to run 1, 2, 3 blocks. Notice we had to run to the left because we need a line that's going to go downhill. If I went to the right, that would give me a line going uphill. So I got to make sure that I run in the correct direction. So here's my y-intercept is 2. I'm going to go up 1 block, and I have to run 2 to the left, or 3 to the left. So that way it gives me a downhill slope. And I can also run 2 down and, 1 down and 1 down and 3 to the right, and then 1 down, 3 to the right. So as long as I'm going up 1 and 3, running 3, I just have to make sure that I'm running in the right direction, and that gives me my line. So see, I went up 1 over 3, I went up 1 block or square over 3 squares, I went down 1 square over 3, and that gives me my line. When we're graphing a line, what are we really graphing? We're graphing the solutions to this equation. So any point that's on that line is going to be a solution to that equation. Let's look at number 3. In number 3, what is the slope? Well, remember there's a hidden 1 in front of that x, so our slope is actually 1/2. And it's positive, so it has to be slanting to the right. Where are we going to start running and rising? We're going to start at the y-intercept. The y-intercept is -4. Remember, you have to start on the y-axis. So the y-intercept is down here at -4. Be careful, a lot of kids will put it here. This is not a y-intercept, this would be an x-intercept, right? Because that's the x-axis, and this is not an x-intercept, it is a y-intercept. So make sure you're starting on the y-axis when you're plotting the y-intercept, or the b. And then we're going to use our slope, and we're going to rise and run. So we're going to go up 1 block and over 2, and we're going to go up 1, over 2, up 1, over 2, and we can go down 1 block, over 2, and we can go down 1 block, over 2. And there is our line of solutions. So let's look at these ones. So these ones are a little bit different. So what is our slope? Our slope is -4, right? So that's your m. So our m is -4, which is a rise and run of 4, up 4 over 1, up 4 over 1, but it's negative. So remember, our line has to be going downhill because we have a negative slope. But where's our b? There is no b. There's no +2, -2, +3, -3. There is no b. So that means our b is actually 0. So our b is 0 in this problem. That's why this problem's different. So on our y-axis, we're starting at the origin. So when there is no b, you're actually starting at 0, which is your origin. And then we're going to go up 4 blocks. And remember, we have to go left 1 block so that we have a downhill slope. And we can also go from the origin, we can go down 1, 2, 3, 4, and right 1 block. That way we have up 4 over 1, up 4 over 1, but it's going downhill. And remember, we are graphing solutions to that equation. So to recap, when there is no b, remember the b is actually 0. And that means you're actually starting at the origin, where the x and y axis intersect. Let's look at the next one. This one's a little bit different. What is the slope in this problem? Well, you would think the slope is 2, but it's not. If you go back and listen to what is the slope is the coefficient of x. What number is being multiplied to x? So remember, there's like a hidden 1 there. So your slope is actually 1 in this problem. So slope is 1, which can be written 1 over 1. So we're going to go up 1, we're going to go over 1. We're going to rise, and we're going to run. And it's positive, so we have to be going uphill. What's our b in this problem? The b is the 2. The plain old number is your b, and that's the y-intercept. So we're actually going to go on the y-axis. We're going to start at 2 because that is our b in this problem. And then from there, we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and we can go back to the y-intercept and go down 1 over 1, down 1 over 1. The more point down 1 over 1, down 1 over 1, the more points you plot, the more accurate your graph is. And remember, when you're graphing solutions. So if you're accurate, you're going to have accurate solutions if you're graphing accurately. Let's look at these two problems. These two problems are different. Notice this just says y equals a number, and this one is x equals a number. When you have y equals a number, if we look at it from a t-table perspective, that means the y value is always going to be 3. Here you have where it just says x equals 4. That means the x value is always, always, always 4. So where on the number line where the y coordinates are always going to be 3? Where is y always 3? That would be here. Y is 3 here. So this line is the y equals 3 line. This line right here is the y equals 1 line. This is the y equals -4 line. This is the y equals 0 line. This is the y equals -2 line. So the y equals 3 line is a horizontal line right here. Let me prove to you. Let's look at some ordered pairs. So what is the coordinate of this location? It has a x value of 0 and a y value of 3. This point right here has an x value of 3 and a y value of 3. This point right here has an x value of -1 and a y value of 3. This point has an x value of -4 and a y value of 3. Do you notice that every single one of these y values are always 3? That's why this is called the y equals 3 line. So y equals a number is going to be a horizontal line where all the y values are 3. So that would be that location. X equals 4, that is where all of the x values in your t-table are always 4. This is where x is always 1. So all of these points that are on this line, the x values are always 1. This line is where the x values are always 2. So if you look at any of these ordered pairs, the x value is always 2. This vertical line is when x is, these all have an x value of 6. This line is where the x values are always going to be 0. And here's where the x values are always -2. So that's what those lines represent. Well, we want where all the x values are 4. So that would be this line here. So this is your x equals 4 line. Don't believe me? Let's take a look at some of our points. Let's look at this point. Isn't this right? This is 4, 1, 2, 3. This is 4. So isn't this coordinate 4, comma, and then doesn't it have a height, a y value of 3? Let's look at this point. Doesn't this have an x coordinate of 4? And isn't its y value 1? And let's look at maybe this point. Doesn't this point have a x value of 4 and a y value of -3? Do you see that each of these coordinates, the x value of the coordinate, is always 4? So we say that this is the x equals 4 line. So as you can see, you've got some lines that are slanted. So here we have some lines that are slanted, and they were in y equals mx plus b. And then you have some special cases where you have just y equals a number, you have a horizontal line, and then x equals a number gives you a vertical line. So some special cases. So let's do a quick summary. So here when you have slope-intercept form, that is where you have the slope and the y-intercept. That's where your lines are going to be skewed. Your y-intercept is where it hits the y-axis, and your slope is gives you the slant or your rise and your run. And if it is a positive slope, it should be slanting uphill. And if it's a negative slope, it should be slanting downhill. And we call these skewed lines. These are lines that are slanted. And then you have some special cases. When you have an equation that just says y equals, those are going to be horizontal lines. So for an example, y equals 3 would be the line, horizontal line there, because those are where all the y coordinates are always 3. When you have x equals a number, that is when you will have a vertical line. For an example, if you have x equals 2, that would be this vertical line. This is where all of the x values are always 2, and where the y values are always 3. So these are your special cases or special type lines, are when you have a horizontal line when it's y equals a number, vertical line when it's x equals a number, and if it's in the form of y equals mx plus b, those are your skewed lines. So that's a little summary.